What if I told you there's a hidden code, a secret architecture that's been hiding in plain sight this whole time, right inside our numbers? Well, a new paper is claiming to have found exactly that, a map for the infinite. It's a question people have been asking forever. Is the universe of numbers just total random chaos, or is there some deep, underlying pattern holding it all together? The paper we're diving into today doesn't just ask that question, it claims to have the answer. Okay, so the first clue to this whole thing starts with something you probably did in math class and didn't think twice about. It's called the digital root. You take any number, let's say 5,834. You just add up its digits, that gives you 20. Still 2 digits, right? So you just do it again. 2 plus 0 is 2. And boom, that's it. That final single digit is its digital root. So right now you're probably thinking, okay, that's a cute little party trick, but so what? Well, what if I told you that simple process, that little number 2, isn't just a curiosity? What if it's actually the key to unlocking a universal framework for every number that exists? And this framework has a name, the Arithmetic Invariant Lattice, or AIL for short. And here's what's wild. The authors are really clear on this point. They say they didn't invent the system, they discovered it, like finding a hidden continent on the map of reality. So what is this thing really? Well, the easiest way to think about it is like a GPS for every number. The AIL claims that every single integer, from 1 to a trillion and beyond, has its own unique, permanent address on this giant cosmic grid. And it's all based on properties that never change, like its digital root. And get this, a direct quote from the research papers says is a framework to treat numbers and symbols as structural entities within a holographic lattice. Whoa. That word holographic, that's a big deal. It means that every tiny piece contains the pattern of the whole thing. It's like every number has the DNA for the entire universe of numbers packed right inside it. Okay, so a map for infinity. That sounds pretty impossible, right? How do you even start? Well, believe it or not, it all begins with something surprisingly simple, a 9 by 9 grid. This grid is built on 2 really basic ideas. First, there are 9 big families of numbers, which they call archetype families. And guess what decides which family a number belongs to? Yep, its digital root. So every number in existence has to belong to one of these 9 families. Then, within that family, each number gets its own unique slot. Think of it as a row and a column, an x and y coordinate for every single number. And here's what that looks like in practice. This is the basic blueprint. See the rows? Those are the archetype families, 1 through 9. And the columns? Those are the slots. So if you take a number like 29, its digital root is 2, so it lives in that second row. Then it gets assigned a specific column, its slot. And just like that, every number has a home, a permanent, unchangeable address. All right, a 9 by 9 grid works great for the first 81 numbers. But what about number 82? Or a million? Well, this is where the whole thing gets really beautiful. The grid is a fractal. The pattern doesn't just stop, it repeats forever. The fancy term for this is scale invariance. All that really means is that this 9 by 9 structure is the fundamental building block. The rules that apply to the number 5 are the exact same rules that apply to a number with a billion digits. The blueprint is constant no matter how far you zoom in or out. And the way it scales is through what the paper calls tiers. Think of it like stacking Legos. The first 81 numbers make up the first block, that's tier 1. Then you just stack another identical 9 by 9 block right on top for numbers 82 through 162. That's tier 2. And you just keep stacking these blocks, one after another, layer by layer, building this incredible structure up to infinity. Okay, this is a really elegant idea, this infinite map of numbers. But what's it good for? Why does it actually matter? Well, according to the paper, once you have the map, you unlock some pretty serious superpowers. The biggest change here is a total shift in how we approach problems. See, usually in math, we're trying to solve for x, right? We're hunting for some unknown answer. The AIL method says, forget hunting. The answer is already on the map. You just need to find its coordinates. It's less about searching for an answer and more about simply revealing an answer that was already there.
And this new way of thinking leads to some incredible claimed applications, like forward projection, being able to predict where a sequence of numbers is headed, or backward tracing, being able to perfectly track a result back to its source, which would be amazing for security and auditing. They even say you can map symbols and letters onto the same grid. But maybe the biggest claim is a new form of lossless data compression, where you could shrink a massive number down to just its simple coordinate.
All of this brings us to what might be the single boldest claim in the entire paper. It's a term from the world of computer science, and it's a really, really big deal. O1 performance. So what does O of 1 mean? In simple terms, it means instant. It means an operation takes the exact same amount of time no matter how big the problem is. So finding the location of the number 7 on this map would take just as long as finding the location of a number with 1 trillion digits. The complexity never increases. For fields like cryptography or big data, that's not just a game changer, that's a whole new game. So let's zoom out for a second. What does all of this add up to? Because the paper isn't just proposing a clever new tool for mathematicians. No, it's suggesting we're looking at the very fabric of reality itself. The grand vision here is that the AIL isn't a human invention at all, but a discovery of something truly fundamental. The paper suggests it reflects a constant clock harmonic, kind of like the universe's background hum, its base frequency. A pattern that can potentially structure everything, from pure numbers to the spiral of a galaxy or the veins in a leaf. It's a profound claim about the inherent order of the cosmos. And that's what this all leads to, really. It brings us right back to that huge, timeless question, is mathematics a tool we invented to describe the world, or is it the underlying language of reality itself, a fundamental structure that was here long before us and we're only just now beginning to map? Let us know what you think.